Okay, so now we come to the third part of the video, okay, for today's asynchronous lecture, and we move to the next section, to, calculating volume using cross sections. Okay, kalau the first two sections just now we have completed for the how to compute the area using integration technique. Alright, okay, so for volume here, okay, how do we relate volume with the area? Okay, kalau you all ingat, okay, I think all of you have come across volume before. Okay, volume, okay, katakanlah kita ada what we call this, a cylinder, right? We have a cylinder, so the volume of a cylinder is actually the area of the base, okay, area of the face multiply with the height, right? So that's why here area of the surface yang kat bawah ni is an area of a circle, so pi r square, and then multiply with the height, okay, height of the cylinder. So kita dapatlah volume of the cylinder. Okay, so for this one, same case, okay, yang ni using the integration technique, okay, volume is equals to, we already regard before this, okay, integration of a curve, okay, macam we have a curve fx, so area under the curve is equal, integration under the curve is equals to the area under the curve, kan? But now we upgrade, okay, we have area, okay, area multiply with, now this dx become the height of your surface that you want to integrate to get its volume. Okay, surface of an area multiply with its height dx here, you will get, okay, integrate from a to b, okay, same like the area, you will get the volume. Okay, nanti kita tengok lagi into details how does this make sense. Okay, area multiply with height from integration from a to b. Okay, we have a curve, actually you can sketch until you nampak dia punya volume tu rupa macam mana. Okay, so here in summary, these are the 4 steps how to calculate the volume of a solid. Nampak tak? The first step, you must sketch the solid and a typical cross section. Okay, bila kita sketch the graph, of course first of all we have to sketch the curve, then daripada situ kita boleh get the solid, we must sketch out the solid, dan daripada situ kita boleh nampak is a typical cross section. Typical cross section ni sangat penting because from there you will able to establish this formula so that you can integrate it accordingly. Okay, find a formula for AX, as I said just now, area of a typical cross section. Then you find the limits of integration, then you may get the integrate AX to find the volume. Ingat tak yang sebelum ni saya cakap, kalau area under the curve we define that we integrate of fx, we consider these as the slices of the rectangle, kan? Kalau kita nak integrate respect to dx, okay, so one by one we add them all, then we get area under the curve, right? So same concept here for the volume also, we'll partition it or we slice it into small typical cross section. Okay, later I'll show you through example, lagi senang. Kalau cakap sekarang memang maybe you all tak nampak. Alright, so we move to straight away this. Okay, so this is what we call as the this method. Okay, the this method. So as I said just now, okay, the formula of the area biasanya kita akan integration is equals to area AX, kalau with respect to x line, AX dx. So AX, first of all you need to know the area. So this is the formula of the area, pi r square, macam saya introduce tadi. Alright, katakanlah, okay, I'll explain to you here this example. We have a curve like this. Okay, kita ada curve macam ni. Apa ni curve ni? Y x equals to y square, kan? Okay, this curve. So you just imagine this curve is rotating respect to x-axis. Okay, this curve is rotating respect to x-axis. Maknanya rotating ni dia berpusing 320 darjah. When it is rotating 360 degree, can you boleh bayangkan tak? It will come out as a solid like this, the bentuk, dia punya bentuk tu. Okay, it will come out like this as a solid. Okay, so daripada sini kita nampak satu bentuk macam ni. Okay, so this bentuk you may compute its volume. Okay, how do we compute its volume using integration approach is that you partition it, you slice it into a disk of volume. Okay, kita tak kira integration tu as dia punya volume as a whole like this, but we slice it into pieces. Okay, we slice it into pieces. So for example, kita potong dia macam you potong roti tu, macam tu. Okay, so we have like this. Okay, something like this, banyak-banyak macam ni dalam, tapi must be sekata lah. So that's what I mean just now. Okay, we partition it into, so kalau kita buat keluar, we get only small disc like this, a small disc like this. So you may compute the volume for each of these discs. Okay, volume for each of these discs, where dia punya radius is from the axis of rotation here up to the curve. Okay, yang curve yang melitupi dia punya volume ni, okay, is our arc, not height, is our arc, the radius. Okay, the radius. So you compute, by knowing this radius, you may get the volume. Sorry, you may get the area of the surface here. Then multiply dengan height. Yang kecil ni is now the height. Ni kita masuk height tinggi lah. Yang ni surface of the circle and multiply with this height. So now you can see the height is sekata, dia punya ni must be evenly distributed. So the width of the height here, or the height lah, kita boleh kata the width, nanti you confuse. Okay, the height here is respect to dx, it's changing respect to dx. Okay, and the value of dx ni sepatutnya sama, dia punya apa, dia punya tinggi tu sama. Okay, so we don't have to think of berapa size dia, it's just dx. Okay, delta x dx, sorry. Okay, but what is changing here is actually dia punya arc. Okay, nampak tak tadi arc ni banyak ni, and now when towards the end, sepatutnya dari A ke B kan. Okay, start daripada A here, this arc ni dia punya arc, but when it comes to complete the integrate the volume ni at the end of the surface, your arc dah makin tinggi. How does arc is changing? The arc here is changing with respect to the curve kat sini lah. Okay, dia depends pada value of x kat sini kan. Katakanlah curve ni is y equals to square root x. So kalau katakanlah arc kat sini 1, x kat situ 1, so maknanya dia punya height here is square root 1. Katakanlah arc kat sini is 4, so maknanya arc is equals to 4, dia punya height now is square root 4 is equals to 2. Nampak? Okay, what is changing is the height, whereas the radius here is constant. The radius pula. The width atau the height of the slice here is constant, which is dx. So that's why what we have here, integration from a to b pi arc x square dx. Arc yang you dapat tu, okay, you just need to squarekan dia. Okay, so meaning to say the arc here is equals to, for this case, y lah, square root 4, or is equals to square root of x, which is 2 here for this case. Okay, so now let's have a look at example 8. Okay, actually the same curve that have been discussed with you just now. We have a curve y equals to square root x, and x varies from 0 to 4, rotating or revolve about the x-axis. Macam saya explain tadi lah, when you rotate, then you will get the solid looks like this. Okay, so daripada sini, okay, we slice into this, okay, daripada sini kita nampak macam saya dah explain tadi. Okay, we have integration of area times with the height. Okay, so as you can see here, the height of the this slice, okay, maknanya kita measure dalam this line is y equals to 0 and this is y1 katakanlah. So maknanya this is radius. R is equals to Y1 minus with Y0, katakan kat sini kan. So Y1U adalah changing with respect to X, and Y0 is always 0 because it's along the X-axis. So your R is equals to square root X. Faham So maknanya katakanlah kat sini maknanya still the same, square root X minus with 0. Kat sini pun sama, square root X minus 0. Depends on what is your value of X here and here and here, where X is varies from 0 to 4 here. Okay, so the formula will become pi square root of X, everything square, dx. The width or the height of this here is dx lah. Setiap slice tu dia punya ketebalan adalah dx. Okay, so the integration left with pi, integration from 0 to pi x dx. So you solve lah integration ni, simple sangat. Then you will get answer is equals to 8 pi. Alright. Okay, then we move to example 9. This example 9 is still the same curve, y equals to square root x, but the difference is that now instead of we rotate about the line about the x-axis, now we rotate about the line y equals to 1. Okay, so this is the line y equals to 1. Nampak tak? Okay, maknanya dia punya rotator, dia punya tu palang dia ke apa, kalau you nak imagine, is at the line y equals to 1. So maknanya when they rotate, dia akan rotate macam ni. Okay, macam ni lah. Dah lukis lah. Saya nak guna yang ni je lah. So you just imagine this is the axis of rotation, y equals to 1. Then when it rotate, dia akan jadi solid macam ni. Alright. So what makes the difference between what we have just now dengan yang sekarang ni adalah dia punya center. When you want to measure the radius. If before this, the radius, its center is at the x-axis of y equals to 0. But now, to measure the radius, dia punya center is at the line y equals to 1. Okay, y equals to 1 kat sini. So, the radius now is y1 minus with y0. Okay, so radius is equals to y1 minus with y0. Now, y1 is still square root x, and y0 is equals to 1. Okay, y equals to 1. Nampak tak? Dia punya ketebalan or height here is still dx. Is still dx here. So meaning to say dia punya integration now, and then take note as well. Okay, dia punya region tu is from x equals to 1 to x equals to 4. X equals to 1 up to x equals to 4. So maknanya integration is integration from 1 to 4 pi. Radius now is square root x minus 1. So pi square root x minus 1 square dx. Okay, so you should able to solve this. Nampak square ni is another again lah, dia integration technique ni square root x minus 1, you expand je lah square root x minus 1 dx. So solve this integration ni. Okay, so you pecahkanlah integration ni, maknanya square root x times square root x is x minus with 2 square root x plus 1. I will integrate respect to dx. Then you solve this integration, you should get 7 pi over 6. Saya tak tunjuk lah. Okay, solve it on your own. Alright. Okay, so now we move to the last part that I want to discuss for today, which is this method rotate about y-axis. Tadi kita rotate, okay, rotate secara horizontally. Okay, we rotate horizontally. Okay, kita pusing dia along the x-axis, along the line y equals to 1 tadi. Okay, maknanya dia punya axis of rotation tu horizontal. But now, okay, we rotate about the y-axis, meaning that we rotate it vertically. Okay, vertically. Okay, rotate about the y-axis or about the line x equals to something lah. So what makes the difference between this is that kalau you tengok, okay, the rotation here become like this. Okay, so your this will looks like this, something like this. Okay, so dia punya radius now, okay, instead of y1 minus y2, then it's going to be x1 minus with x2 ataupun x0 something. Okay, and the height of the radius will become respect to y, dy. So that's why you see here the integration jadi macam ni. Okay, integration from c to d ay dy. Okay, now look at example 10. Find the volume of the solid generated by revolving the region between the y-axis and the curve x equals to 2 minus y. Okay, the curve x equals to 2 minus y ni given to you already. Okay, where the curve is like this. Okay, so since it is it is bounded by y equals to 1 and y equals to 4. Okay, ni dia punya region. Okay, dia punya region. Then when you rotate about the y-axis, nampak tak? Okay, dia macam ni. Okay, sorry lah tak cantik sangat. Okay, macam ni. So this is the region. So when it rotate about the y-axis, dia akan jadi bentuk macam lampu macam ni. Macam tu. Okay, bentuk macam lampu. So this is a solid that we want to compute its volume. Okay, so with that, maknanya kita slice it this way. Kita slice macam tu. So when you slice like this, okay, kalau kita ambil satu slice ni, okay, this one, you can see already where the radius of this slice is from here to here. Okay. Okay, where this line is, saya letak sebagai x0 lah, x0 equals to 0. X0 equals to 0 or y-axis. And this curve, okay, this curve, katakanlah x1 is equals to 2 over y. Okay, so maknanya dia punya radius for each of the slice r is equals to x1 minus with x0, where x1 is 2 minus y minus with x0 is 0. And dia punya height ni adalah, nampak tak, dy. Okay, means the radius dia, center of the radius is along y-axis or x0 equals to 0, and the radius is keep on changing depending what is your curve x1 here, because dia punya radius is x1 minus x0, and x1 here is changing respect to y. Katakanlah y equals to 1, x1 awak akan sama dengan 2, so 2 minus with 0. When y equals to say 4 here, y equals to 4, then your x1 is equals to 2 over 4, so it's equals to half. So maknanya half minus 0, radius jadi separuh. Yang ni radius jadi 2, and so on and so forth. Okay, so maknanya kat sini dia punya volume is equals to pi, saya buat keluar siap-siap. Okay, pi integration from 1 to 2 minus y square dy, where dy here representing the height of your disc, ataupun ketebalan pun boleh jugalah nak cakap of your disc. Okay, so you solve this integration. I'm not going to solve this, it's too simple. So you should get the answer is equals to 3 pi. Alright. Okay, so this is the last example for today. Example 11. Find the volume of the solid generated by revolving the region between the parabola x equals to y square plus 1 and the line x equals to 3 about the line x equals to 3. Okay, about the line x equals to 3. Okay, so here about the line x equals to 3, kalau tadi we are rotating about the y-axis, but now is about the line x equals to 3. So this line x equals to 3 ni kat sini. Okay, so now this x equals to 3 become the center of your radius. So kalau you imagine it's rotating 360 degree, it looks like gasing macam ni. Okay, it looks like gasing macam ni, and this is the center. So you slice it into the disc, looks like this. Okay, and the width of the disc, or dia punya height of the disc kat sini, ketebalan disc ni adalah again changing with respect to y, so the dy, and then the radius. Okay, radius dia sekarang ni, center of the radius is kat sini, x3 ni kat sini, x0, ataupun nak buat xc pun lagi cantik sebenarnya, xc represent center. Okay, x0 minus 3, and then dia punya ni radius dia ni, okay, dia punya kelilik dia adalah kat this curve. Okay, this curve where x is equals to y square plus 1. Katakanlah saya put this as x1 y square plus 1. So meaning to say your radius is x1 minus with x0. So y square plus 1 minus 3. Okay, so daripada sini oh sorry, okay, I just made a mistake tadi. Saya letak x1 minus with, okay, I made a mistake. I was saying x1. Okay, ni yang saya tulis tadi, r is equals to x1 minus with x0. Okay, tapi sebenarnya it was a mistake. Why it was a mistake? Sebab cara betul dah tolak tu, tapi you tengok dia punya center now is to the right of the ukur lilit dia, x1. Okay, maknanya kita tak boleh always x1 kena tolak dengan x0 ataupun xc kat sini, center. Saya rasa guna c lagi bagus lah sebenarnya. Okay, x1 minus with xc, because for this case center is to the right of your ukur lilit ni. Okay, of the curve of your curve here. So meaning that this is wrong. Ni tak betul ni. Yang sebetulnya adalah xc minus with x1, because center is to the right of your curve. Okay, so that's why maknanya kita ukur dia dari 3 tolak dengan 2 minus y square. If you proceed like this, you will get negative value. Okay, so ya, maknanya kita dapat 3 minus with 2 tolak y square. Okay, 3 minus with 2 tolak y square. Okay, oh sorry, again I made a mistake. Okay, 2 minus square y square ni silap juga, because this is already the radius. Dekat curve ni dia dah siap untuk cari radius. Yang kat sini sepatutnya saya guna. Okay, 3 tolak dengan dia punya radius, dia punya x1 dia adalah y square plus 1. Barulah dapat 2 minus y square. Silap ni bukannya 2 minus y. Yang ni memang dah salah. Okay, this one is supposed to be y square plus 1. Y square plus 1. Y square plus 1. So that you will get answer here 2 minus with y square. Jangan silap, saya tersilap ni. This is already this curve is already given you the correct value. I mean the radius dah ni, bukannya baru nak kira radius. Here this curve, this graph baru nak tunjuk kat you macam mana nak kira the radius. Okay, so from here you may set up the integration. Okay, so daripada sini kita tahu dah sekarang ni. Okay, so we have already the radius is 2 minus y square. So you may set up the volume. Saya tulis kat sini integration from your dia punya radius kat sini is starting kita rotate macam ni kan. So maknanya dia punya dy, okay, dy, and integration is from starting from this line. From this line is y equals to 0 sampailah y sama dengan berapa ni? Okay, at this point dia sampai kat sini dia punya region. This is when x equals to 3. So when x equals to 3, what you will get for y? Kita ada equation ni, x equals to y square plus 1. So when x equals to 3 minus 1 equals to y square. So your y is equals to plus minus square root 2. Tapi kita punya region, okay. Okay, so maknanya sekarang ni kita punya region of integration kita daripada y equals to negative square root 2 sampai y equals to square root 2. Daripada atas sampai ke, dari bawah sampai ke atas here, negative square root 2 sampai ke square root 2. So integration is from negative square root 2 to square root 2. Pi letak kat luar, your r now is 2 minus y square, everything square respect to dy. Okay. Okay, so this is the integration. V sama dengan pi from negative 2 to negative square root 2 to 2 minus y square power of 2 dy. And kalau you nampak, this is symmetry. Okay, ni adalah symmetry. Maknanya the volume of this is equals to volume of this. Sebab gambar ni pun dia simetri kan. So maknanya kalau consider area pun area yang ni sama dengan area yang ni. So you may you may simplify the integration by just consider integration from 0 to square root 2 sahaja. From 0 to square root 2. 2 minus y square everything square dy and just multiply by 2 sebab sama je nilai volume yang daripada kosong hingga square root 2 adalah sama dengan volume daripada kosong ke negative square root 2 sebab daripada gambar area ni pun kita tahu luas yang ni sama dengan luas yang kat bawah, so 2 kali ganda sajalah. So you solve this integration on your own, then you should get this answer. Okay, so with this, we have completed today's asynchronous lecture, and for classwork submission, it's very simple now. I want you to complete the solution for example 10 and example 11. Okay, untuk make sure that you betul-betul faham. Okay, so integration setup saya dah bagi, from mana ke mana jawapan pun dah bagi. I want just you to show that you have completed and tried the soalan and you get the correct answer. Okay everyone, so you need to solve example 10 and example 11. If you listen to my video, there's no problem. You just need to you just need to integrate, ganti dengan value lower and upper bound, then you should get the answer. Answer pun dah bagi. So maknanya kita boleh tahu sama ada you get the correct answer or not. Alright, so that's all for today's asynchronous lecture. Thank you very much and Assalamualaikum warahmatullahi taala wabarakatuh.